So in covalent compounds, every atom has something called a formal charge. Now, you know in ionic compounds, you have ionic charges. So like sodium. Sodium has 11 electrons in its neutral atom, but it gets rid of an electron, so which means it ends up with 10 electrons, which then it has an overall charge of +1. That is the ionic charge. Formal charges are kind of the same thing, but in covalent compounds. It has the number of electrons it has as a lone atom, and you figure out the difference with what it has in the molecule itself. So that's this equation right here. So to figure out the formal charge of an atom in a covalent molecule, take the number of valence electrons in the free atom, so that's before it bonds, minus the valence electrons assigned in the molecule. Assigned electrons are lone electrons, or the unshared pairs, plus 1/2 of the shared electrons. And you get the formal charge for each of the atoms in a molecule. And if everything is done correctly, the sum of each formal charge of the atoms adds up to 0 in a neutral molecule, or whatever the charge of the polyatomic ion is. That's the sum of the formal charges. So, for example, we'll do an easy formal charge problem here. We're going to find the formal charges for oxygen and hydrogen and water. Okay, so for oxygen. All right, so number of valence electrons in the free atom. So an oxygen's by itself has 6. All right, and that says minus the electrons assigned in the molecule. Okay, so assigned in the molecule, well, we count these. So those are the unshared. So that's 4 plus 1/2 of the shared. So it's sharing 4 electrons between the 2 hydrogens. So we take half that amount. So that is 2. All right. So we say this is a free atom, unshared electrons, and 1/2 shared electrons. So we do that. Oxygen's formal charge is 6 minus 4 plus 2, 0. Okay, if we do the same thing for hydrogen, all right, well, valence electron in the free atom is 1. So 1 minus unshared electrons, 0. Shared electrons and half of them, which is the bond has 2 electrons, so we're taking half of that, 1. So that is 0. So the formal charge for oxygen is 0, and the formal charge for hydrogen is 0. Now, overall charge for H2O has a 0 charge. Well, 0 for oxygen, 0 for hydrogen, 0 for hydrogen, they all add up to 0. So that's how you figure out the formal charge of atoms. All right, so we'll try another one. Xenon tetrafluoride. All right, so xenon. So xenon as a lone atom has 8 minus the number of unshared electrons, 1, 2, 3, 4, plus number of shared electrons. So 2, 4, 6, 8. Half of 8 is 4. So 8 minus 4 plus 4 is 0. Yeah, if we look at fluorine, let's look at that. 7 is the valence minus shared 1, 2, 3, 4, 5, 6 plus 1/2 of the shared 1. So again, that is also 0. So here we go. Those are formal charges for xenon and fluorine in XCF4. Okay. Now here we have an ionic compound, Cn minus. So let's look at carbon. Okay, carbon is 4 electrons when it's by itself, minus All right, unshared, there you go, which is 2. And shared, 2, 4, 6. Half of 6 is 3. So 4 minus 2 plus 3, -1. Nitrogen. All right, nitrogen has 5 in its valence, or 5 in its free atom, minus. All right, the unshared, which is 2. And then 2, 4, 6. Half of that is 3. So 5 minus 2 plus 3 is 0. Okay. Now, the overall charge of Cn minus is -1. Well, carbon has a -1, nitrogen has a 0. So if we add those two up, that's -1. So overall it's a -1, which is what our polyatomic ion charge is. So there we go. All right, so the last one I'll show you, sulfate, SO4 minus 2. So we're going to look at sulfur and oxygen. Okay, so sulfur has 6 electrons in its free atom, minus 0 unshared. 1, 2, 4, 6, 8. Half of 8 is 4 shared. So that gets you 6 minus 4 is 2. And then oxygen, so each oxygen, 6 electrons in its free atom, minus unshared, 2, 4, 6. And then take half of that, so that's 1, so 6 plus 1. So 6 minus 7, -1. And then since you have 4 oxygens, that's overall -4. Add those up, it gets you -2. There you go. So those are your formal charges for SO4 minus 2. Now, I'm going to do a little twist here. This is another way to write out the structure for SO4. And it's still accurate. Everything had the same total electrons, 32 electrons. Each oxygen satisfies the octet rule. Actually, sulfur, 2, 4, 6, 8, 10, 12. Sulfur is holding up to 12 electrons, which it can do. So we're not doing anything wrong there. All right, well, let's check out the formal charges here. So we'll say oxygen, 1 oxygen, and the second oxygen. So we'll call this the first oxygen, we'll call that the second oxygen. Okay, so again, sulfur, valence, or free electrons, 6, minus, all right, so shared electrons is 0. And then we take 1/2 of the shared, so 2, 4, 6, 8, 10, 12, so that's 6. 0. Okay, now 1 oxygen up here, so the one with the double bonds. So 6 in the free atom, minus 2, 4 unshared, plus half of the shared, so 2. All right, and then the other oxygen here with the single bond, so 6 minus unshared is 6, shared is 1, so that's a -1. All right. So now, if you look at this, 0 times sulfur has an overall charge of 0. 0 times 2 for your 2 oxygens, 0. -1 times 2, -2. Okay, so it still matches that. All right. So now you gotta ask yourself, all right, so which one's correct? All right. This is where you really need formal charges. A molecule wants the lowest formal charges in its atoms. Now, lowest meaning closest to 0. That's the lowest. So it doesn't want to go any farther negative or positive. All right. So by looking at these, here sulfur is a +2 versus here sulfur is a 0. So sulfur is closer to 0 here. Oxygens, all 4 oxygens have a -1. Here we can get 2 oxygens at 0 instead of -1. All right. So that means you got more atoms here with a 0 formal charge in this bottom molecule than you do this one. So this one would be the more accurate Lewis stat structure because of the formal charge. Right? So if you can create a molecule with a Lewis stat structure, figure out the formal charges. If you can do it a different way and it gives you lower formal charges, take that way. Take the one with the lower formal charges. All right, that's everything about formal charges.